Hello. 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 Can you
Hi,
guys
Shiva.
hear
Hi,
me?
Shiva.
Yeah, Shiva.
Okay.
Yeah, Shiva.
Yeah, I was just checking whether I was audible or not. Okay. So no confusions, right? Today, I mean, people joined on right time, or you guys?
Yeah, no confusion for us.
Okay.
We know.
Okay. Yeah. So let me start sharing my screen. Okay. So in our last session, so we were talking about the Scala collections at the end. So we talked about list and set and some of the operations on them. So we thought of discussing map and any pending stuff like tuples and these things. So in today's session, and then we'll continue. We'll get started with the Spark concepts. Okay. So I hope you guys can see my screen. Let me see if everyone joined or not. So Dharmesh, Dhruva, Jags, Kalai, Mahesh, Raj Patel, Revati, SJ. Is SJ Sujit or?
No, Shiva. This is Sujit here. So I've joined with my name.
Okay, you joined from two computers?
Yeah,
No.
Shiva, this is Sunil. I have joined from mobile as well as laptop.
Oh, okay.
Yes.
Okay, no problem. Yeah, no problem. No problem. Yeah. So Snehali is not there, I think. Okay, so rest all are there. Yeah. So yeah. So do you guys need a quick review of what we discussed last session, or shall we get started with the today's topics itself? Because last session we were talking about only the collections, and before that exceptions, what we and traits. Okay. So in collections we talked about list and a set. That's where we stopped it. And in every collection we have two flavors, like, so one is a mutable version and second one is a immutable flavor package or the class. So mutable ones are available in scala.collection.mutable, and immutable ones are available in scala.collection.immutable collection package. And list and set, all the operations are also look pretty similar. Only thing is set will have the unique values, and lists may have duplicates as well. Okay. And coming to the map, same as your Java collections maps here as well. These are key value pairs, and any value for a given key is retrieved based on the key, and keys are unique in the map, but values need not be unique. Okay. So for the same key, so multiple values can also be get assigned, or the value can be repeated for different keys. By default, immutable maps will be created whenever you create a map. And for creation of a map, it's a simple, same like So we were creating the lists, val list equal to, so list of your strings or numbers or whatever it is. And similarly, val set equal to set of, this way we were creating, right? And now val map equal to val map m1. So if you create, you have to specify your key and value separated by arrow, and any number of this key value pairs can be specified in your this thing. For example, name Jags, again name, another name SP, or you can, or so country codes. Let's say if I'm taking here, the keys should be unique, right? Here, so then I should not be taking this. So age, some 35 or so. So you keep on adding values to it. You can specify these values at the time of map declaration. So anything left side on your arrow is a key and right side is a value. Okay, so this is a single line arrow, not like 2 lines arrow where we were using this for a function definition, right? So f colon int arrow int. So this was for denoting a function. But if you specify this single line arrow, that is nothing but a key value pairs are separated inside a map. And for example here, so I have defined a state codes and their full forms. So all the different state codes will be keys and their descriptions will be the values. And when I create the collection by default, so val states equal to map of so and so value. So if you see, by default it's creating you an immutable map. But if you want a mutable one where you can add, so the same formula, same format, declare this as a var and select this complete package Scala dot collection mutable dot map. This creates the mutable version of it. Okay. So in this, so when you declare this immutable one, so you can just keep on referring those values. That's it. If you need the ability to keep on adding a new key value pairs, so then obviously you need to declare that as a var and a mutable version of it. Then, so how did we see that So we saw that in for list or set, addition of elements, new elements just by element plus equal to your new element, or the list equal to. So the right side element will get added to your list or set. And the same way here for maps also, your key value pairs can be added by just plus equal to. If you want to remove, minus equal to. And if you want to add another list, plus plus, another map. Okay, sorry. And if you want to look through them, so we have on a map, we have a method called keys, which retrieves all the keys as a list. So if you observe here, I have declared a map with the keys, all keys are left side comma separated, and their values, the color name, and their color code. And colors.keys will return all the keys as a list. That returns all the keys as a list, red, azure, and Peru. And on lists, we have a method called for each. As we have seen here in the list, for each is to iterate through each element of this list. Okay, I think if we didn't discuss that, we'll discuss them in the next slide. So what are all the important methods on that? So for each key, for every I, so that this is an anonymous function. So I arrow means for every key that receives. So I'm just printing the key and printing the value of it using the colors of by passing the key. And this prints this way. Okay, so this way, if you need a mutable map to declare, keep on adding elements and deleting elements and iterating them through this method. And if you declare only the immutable version of it, you'll just be able to iterate through them. So mostly we'll use that map.keys dot for each, and for every key we'll loop through the values of it. Okay, so I hope this is clear for you. Next, the tuples. So tuple is nothing but kind of structure. So till now, whatever the collections that you have seen, as we discussed even in the last session, the list, set, or map, all these are homogeneous. So once you declare a list as a list of string, or as a set as a set of string, or a map of string comma string, then you can add elements of those data types only. You can store elements of that data types only. You cannot mix strings, integers, floats, doubles all together in one collection. So that nature you can achieve through your tuples. And tuple is, if you are coming from C language, tuple is equivalent to a struct. And if you are aware of pig scripts, tuple is exactly equivalent to your tuple in pig. But the difference between the tuple in pig and tuple in Scala, in Scala we can only add a values up to 22. So maximum of 22 elements can be added to a tuple, whereas pig does not have that limitation. That's the only difference. It's a row, or it's a set of fields, or in SQL terminology, if you want to compare this, this is equivalent to one row. Okay, let's say, so you have a table So you have a table employee, so where name, age, ID, and department. So you can declare it's a record with a tuple of name as Dharmesh and age as 30, ID as 101, and department again you can big data. That is one row, and this is another row. Okay, analytics. So your rows can be represented with the help of your tuples, or those can be read as a tuple. Okay, but how we can map them with the tuples and all those things, we'll see them in the Spark SQL. Okay, and in tuples, just give the tuple of and give any number of values. How many ever values that you specify there, how many ever fields that you specify inside it. We actually have a 22 tuple classes, like 22 or 21. So tuple of, if you specify 1, 2, just 2 strings, so this becomes like a tuple 2. And if you specify 1, 2, 3, this becomes like a tuple of 3. You can define that way as well, tuple 3 of this. And if you have 4, so you can specify tuple 4 of 1, 2, 3, 4. Or you can simply leave this numbering and you can just use tuple and provide your fields. Yes, Nayali.
Like you said, in tuple, we're going to have 22 values, one tuple. So can we have a tuple in a tuple?
Tuple.
Can we have a nested tuples over there?
Nested tuples, I don't think so.
Because in Pig it's allowed. Pig we can do that. That's why.
That is tuple inside a tuple. Yeah, that is allowed in using.
Pig
Correct. In Pig that is allowed, but here we don't use that. This tuples are mainly meant for mapping with your table columns.
So suppose if my table has say 40 columns, then how do I define a tuple in here?
That we'll see there. I'll explain you the problem and how to solve that. And I'll show you that real-time scenario for that.
Okay, thank you.
Okay. So either you can use tuple 2, tuple 3, tuple 4, tuple 5 like that also, or you can use simply the tuple, and which we recommend, or simply just specify val t equal to a list of values that automatically gets used by that tuple. This is the more the frequent form of usage, just val t and specify any number of values that you have. And while accessing those tuple values back, we access them by the positional notation. So if I have to access 4, I can access that by t dot underscore 1. And 3 can be accessed by t dot underscore 2. And 2 can be accessed by t dot underscore 3. And 1 can be accessed by t dot underscore 4. Okay, and so that's about tuples. So the next one, the iterator. So this is a same like here in Java collections, the iterator that we have. Here in Scala, mostly we don't use this iterator because of a couple of reasons. Other alternatives are available, but still, if you want to get a iterator, iterator means it's a kind of control using which you can access element by element. Okay, so for example, I have a list 1, 2, 3, and on any collection, not just list, on lists or set or map or any collection, you will have a method called toIterator. The collection.toIterator that returns an iterator, and on iterator mainly you will have two methods. So one is iterator.hasNext, means it returns a boolean value, true or false. If the next element is present in that collection, then it returns true. So while that next element is present, as long as the next element is still existing, so I'll keep on processing those elements. So iterator.next, it retrieves that next. This while loop, while it.hasNext, println of it.next prints all the elements of this. And the simplest way, even more simpler way than this, fetching an iterator and checking for the next element and accessing that next element using these three methods. So to get the iterator, you have to call toIterator, and to check whether the next element is present or not, you have to call hasNext, and to get that value, you have to call that next. This is same as your Java, but so we have even more simple option, that is the for each that we have seen in the maps already. So on any collection, so almost all the collections we have for each method also. So it automatically loops through the for every element of this collection. And that's the reason why we don't recommend the iterators. So, but using iterator for a collection is not a good idea, as we have map and for each methods and collections to iterate them. So for each we have seen, map we will see in the next slides.
Shiva, one question here.
Mm-hmm.
So the for each only works with map, or it works with your list and set as well?
So for each works with all collections.
Okay.
Okay. And so best use case of using iterator is when reading file, because putting all file data into memory is not a good idea. If it is just a collection, then go with a map and for each, that is, whereas if it is reading a file record by record, so then that on that file, when you read that file, it might return you the collection of lines, and in that case it might, if it is a very huge file, then you might sometimes may use this iterator as well. Otherwise, almost all the cases we go for either map or for each, and most of the scenarios we go for map only. So if you see, if we discuss the map functionality use case, then you'll find it that is even more frequently used. Okay. Yeah. So out of all these collections, the common methods that you can apply on them is the for each, map, filter, and reduce. So here, I'll explain this with the help of examples only. So I have this a list, LST, And for each, just now we discussed, like it iterates through each element of this. So list dot for each, inside for each, in all these methods. So they expect for each map, filter or reduce. All these 4 functions on collections expect another anonymous function as a parameter.
So Shiva, when for this for each collection, what is the end criteria? Like do while loop, we have an end criteria. This is the time when it terminates.
So it ends once it reaches all the elements. Once it
So,
processes.
for example, if we have an iterative list, for example, which has been generated through, like it's been passed from somewhere, and we don't know how much is the limit. It can be 10, it can be 20. Like it extends depending on the data that we have. For example,
Yep.
in a scenario we don't know what is the end of a list, then what do you do?
You don't need to do that. First thing, you don't need to worry about where that list ends. You don't need to specify how many elements you have to process. Your intention is that when you want to process a list, you want to process that completely.
Okay. So whatever at that instance is the values of the list, that would be the for each will place. So there is no end criteria to be placed.
There is no explicit end condition. It automatically ends after processing the last element of your collection. Okay. Now, so on this list dot, either for each or list dot map or list dot filter or list dot reduce. All these 4 functions are very, very, very important, and mostly, yeah, all are equally important, I can say. Okay. Now, so one similarity is that all these 4 functions expect another function as a parameter. So all these 4 functions expect another function as a parameter, fun, and this fun, okay, and this expects another fun, and this expects another fun. Okay, so input is a function, right? So sorry, input is a list, and you are passing a function as a parameter, and this so for every element that you pass, for every element that you pass, you may produce for every x arrow x kind of stuff. So this function fun, so most of the times, 99% of the times, we define anonymous functions only. So this every x arrow x, meaning this x means every element present in this list. So one element at a time will be processed or passed to this, and inside the right side of it, inside this anonymous function, the right side of it, whatever you want to do, you do it. So if you simply want to print it, so do the print. But so for every element that you pass as input to this anonymous function, this produces one result. So what I'm trying to conclude here is that if you pass 10 elements, you will get 10 elements as output also. And mostly this for each is so not just for processing, and you might have another extra processing for every element if you have to further process this. So we might use this. So for every element, so X that you receive, so if you want to parse that, let's say if this is a line, this is not a string, just 1, 2, 3, 4. You read a file, and every line is nothing but one string for you. And if you want to parse that line, okay, so in that case, I'll make this as line, and line dot split by. So let's assume that is by comma separated. And you collect that into another val list or something. And you can again look through that here in this, or whatever the use case. So this way, if your list is having 10 elements, this for each, and there is one more map kind of stuff, flat map, even that we are not discussing at this moment, but that is more or less similar to this for each. Okay, so let me put that as well here. List dot flat map. Okay, but on high level, so every element that you receive for each, you can further process on the right side of your anonymous function. If you want to print it, print it. If you want to parse it, parse it. If you want to transform and do whatever you want to do, you can do that. Okay, we will come back to this flat map in a few minutes. Next, we have map method. Map method, its characteristic is like, if you pass 10 elements, so after processing that map method, even in the result you will get 10 elements. Then in those scenarios, you use the map method. Exactly for your input 10 elements, you will get in the output also 10 elements. The values might get changed. For example, so one simple function that I can tell you. So for every X, give me X star X. So in my input list, I have 1 to 10. And in my output list, this produces 1, 4, 9, like that, right? But the number of elements, even in my output list, is 10 only. And for a map method, your input is a list, even output is a list. And both input list and output list should have the same number of elements. The values might change, but the number of elements should be matching. The count of elements should be matching both in the input list and the output list. And in filter function, this also expects an anonymous function, and its result is also another list. The filter function can be applied on a list. Input is a list and output is also a list. But the output list, the number of elements may be less than or equal to your input list. For every X, return only if X greater than 1. Meaning, so all the input elements will be validated against this X greater than 1. So only if they are greater than 1, those elements will be copied into your output list. So here again, same like map, output is also another list. Now coming to the reduce function, this input is a list, but output is an aggregated value or just a value. Meaning just one element. You will get output as just one element. It's not a list. Output is not a list. And in this reduce function, so we'll say for every key value pair that you receive, let's say if I receive every two values, x, y, this is also another function that takes two values at a time, two parameters at a time, and returns the x plus y for them. So if you have a list with 1, 2, 3, 4, so automatically if you call this reduce function on this list, let's say if this is a list, on this list if you call the reduce of every x comma y, return x plus y. Okay, so if you simply declare this list of this, it returns the sum of all these elements. It takes every two elements at a time. 1, 2 will be taken first and returns 3, and that 3 is considered for the next element. 3, 3 is treated as x, y, and 6, 4 will be treated, and finally value 10 will be given. See? And map method. So if you apply map for every x, I want values to be doubled. Okay? Return 2 star x. See, the output is again another list with the values got doubled, but the number of elements are same. And filter, for every x, so x greater than 2, those only needed for me. So even from filter, the result is another list with lesser number of elements, or at max equal to the number of elements in the input list. These three functions or methods are very, very, very important on the collections, and you will use them a lot in Spark. And the next one, so if you, for each is generally, instead of producing another list as output, so we'll simply, for execution statements, if you want to print ln or something, print ln of each of this x, okay, for every x arrow, just to print ln. So 1, 2, 3, 4. So for every x, you simply can return x as well. But this is not returning you a list. It just executes that. That is the difference between for each and map. So in a map and for each, you are iterating through every element. In all these methods, you are iterating through every element of your collection. But in a map and filter, your output is again another list. And in reduce, it's just one element, it's not a list. And in for each, you'll not get neither a list nor an element. You simply use that for any kind of executions. And so what was the other one? The flat map. So you have seen a list with, when you have a 10 elements list and your map is producing again 10 elements list, and filter is producing lesser number elements of list. So flat map is exactly similar to your map. Only difference is that the number of elements may not be equal to the number of input list elements. Once you apply flat map, your output list, again output is also a list here, output is list, and this list may contain more, or may contain less than or equal to, or more than or equal to. It may not be equal to the number of elements, more or less than input list elements. It may match the element count also. It's not guaranteed that how many number of elements that you will get in the output. So technically, I hope you got the differences. So when you will be using these functions, you will see them in our Spark examples. But these four are 5. So for each, flat map, map, filter, reduce are very, 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 very frequently used. If you are writing at least a simple Spark program, you will not write without using at least any one of them. You will get to know. So what's the reason behind that? So example of flat map. Yep. So I think you might have got the examples for these three, and for each example of flat map. So I read for flat map, I will give you now. So difference between flat map and map. Yeah, that's what I told you till now. So difference between flat map and map, the number of elements may not be equivalent to the number of input list elements. Here in map, if you pass 10 elements, the output list will also exactly have 10 elements. And in flat map, that is not guaranteed. That's the only difference. Now coming to the example here, let's say I have lines. Okay, so lines is a list. Hadoop is a essential tool for big data. Okay, and Spark runs faster than Hadoop. Okay, so if I declare this lines list of this, how many elements are there in this? Val lines. Okay, so how many elements are there in this? Only 2 elements, right? So this is one string, complete one line, and this is another line. Now I want to split them into different votes. So split by, for every line I want to break that into votes. What I can do is lines dot Now, if I apply map, yeah, I'll show you the difference exactly here. If I apply a map here, for every string str dot split by space. So for every string, I'm using str dot split by space. Now, since I used map and my output list also should have the same number of elements, it returned me. The output is again a list of 2 elements only, but this time the elements are of arrays. The first element is an array, second element is an array. This is an array of strings and this is an array of strings. But if I apply flat map here, capital. See, if I apply flat map, if you observe the differences between this output and this output, all your values got flattened out, right? So Hadoop is essential tool. There is no restriction that it should maintain only 2 elements. Since in map, it has a restriction that it has to maintain only 2 elements, it maintained in the form of 2 arrays. Now, here there is no restriction on that the number of elements count is 2. So it produced this many elements. So for the first string, it produced this many elements. Hadoop is essential tool for big data. And for the second string, it produced Spark runs faster than Hadoop. And this difference is very important. Yeah, I think, is it similar to flatten and pig? Yes. There were same words in both the list. There were same words in both the list. Obviously, it will come as a duplicate. It's not a big deal. It's not, you're not maintaining. It will not eliminate the duplicates. All it does is, it applies your anonymous function. It makes sure that all the results of each element operation will be combined, and the combined result will be sent to you. Here the results are not combined. For the first line, this is the result. That result is put inside a one array, and for second line, this is the result, and that is put inside another array. So you got a result of arrays. Result by using arrays. So can remove duplicates. So that's a different scenario. On this list, you process them or you store them as a set and then eliminate the duplicates. That's a different scenario. The next level operation. So flatten will remove duplicates in pig. No, right? Okay, so duplicate, distinct. Okay, you're talking about distinct bag, correct?
Right. So like multiple statements we can run and clean up the duplicates.
Correct. Yep. Yeah, here also you can do that. The next level of processing, you can remove the duplicates.
Okay.
Okay. Yeah. So, but these 5 functions or methods are very, very, very important. Okay. So the next one, using the Java code in Scala and Scala code in Java. I think we have already seen this, and unfortunately I don't have this Eclipse, Scala Eclipse setup in this laptop, I think. So you can very well use your Java code inside your Scala program. The simple example itself. So all these are Java classes, right? Import java.util.date and import java.text.date format. Text.date format dot underscore. So all these are from Java packages. Means all this is a Java class only. And this is my Scala object, right? I can very well inside my main method. So I can simply create the object of this new date. Same like here. So this is by using the Scala syntax only you have to create. But if it is Java way of creation of an object, so you'll be specifying this as a date D1. So when you are importing, import java.util.date. When you are creating an object in Scala, we use val dt equal to new date. Whereas if it is in Java, date dt equal to new date, right? But when you are using your Java classes inside your Scala, we follow the same Scala syntax only. It's just that you import whatever the classes that you want to, you create an objects for them and call the other methods date.get, whatever the methods that are available, similar to your Java methods or Scala methods. Nothing difference in that. Okay, and building Scala applications using Maven or SBT, I'll directly show you in the Spark project there. So the time of execution of the Spark projects, I'll directly show you how to build a Scala application or yeah, I need to download all these Scala Eclipse IDE and all on this machine. Okay, so now except building Scala application, you have learned almost all the important necessary things inside your Scala. Okay, so this Maven and SBT building tools, I'll directly cover in the Spark sessions itself. With the examples of Spark programs, I'll explain you that. Okay, so far, any questions?
No questions as of now, Shiva.
Okay. If not, then so let's get started with Spark. Okay. Okay. Yeah. So let me okay. Let me close all of this stuff. So in the Spark, let's see today. So the Spark binary tarball installation. Let's focus for Spark installation and Spark overview. Overview, I think we have discussed already in the demo session, and Spark shell or Spark context related stuff we'll cover today. And so bit advanced, anything advanced, we'll see from tomorrow onwards. And as I requested you guys to be available for one extra session, are you guys ready for tonight IST timing, which means tomorrow morning for US guys?
What time you EST?
EST, it would be, I want to plan it around 7:30 p.m. 7:30 p.m. IST, which means 9 a.m.
Yeah, 9 is okay, Shiva. I think we are fine. 9:30. I think we are okay.
9 is okay. Yeah.
Hey Shiva,
Yes, Raj.
can you set at 10 a.m. because tonight I have actually job at we have a Christmas is nearer, so we have a major update in entire Canada for our telecommunication.
Okay.
So that's why I have a job up to like tonight 11 p.m. to early morning 9.
Okay. So you need at 10 a.m. That means 8.
9:30 is okay as well. That's fine. Just after 9.
Okay. So 9:30 fine means then 8 p.m. IST. So 8 p.m. IST means is it 7:30 a.m. or 6:30 a.m. PST?
8:30 means 6:30. Right, Shiva.
Okay. So I mean, if it is 9:30 a.m. Eastern means 3
7.
hours behind PST, right?
Yeah, 7 is for you guys. 9:30.
No. See.
7 for you, 9:30 for us.
No,
right?
not 7. It's 8 p.m. for us. Forget about. Let's plan in US timings only. I'll tell for IST guys. It's 9:30 a.m. Eastern, which means 8:30 a.m. Central, 6:30
6:30
PST. Got it.
PST.
Yeah, I think Dhruva, it's
So
going
it's
to be
gonna be for one. It's gonna be for 1 hour or 1.5 hour.
1.5 hour at least.
You have any plans, Snehalaji?
Who's this? I know.
No, just I'm asking, if you have any plan.
No, I'm
So
good.
I might not
Thanks
take
for
more
asking.
than
Yeah.
I might not take more than 90 to 120 minutes.
Make it 90, not 120.
Okay. Yeah, even that's fine.
Thank you.
But I'm a little worried that Dhruva is from PST. It's 6:30 a.m. Will that be okay for you, Dhruva?
That's a bit challenging for me, but I have to try it. So,
Are there anyone else from PST along with you?
I don't think so. I'm the only one who is from PST.
Okay. So can you?
That's fine. That's fine, Shiva. Even if I miss, I can get I can catch you guys with the recording, so it should not be a problem. So.
No, if it's half an hour or 1 hour, it's okay, right? We can adjust. Everyone should come in the.
Yep.
It's not missing or something, but if it's half an hour difference, we can, prepone or postpone.
Yeah.
I think we all are good. I mean, especially the EST people. I think we are good to go half an hour plus minus.
Yeah, plus or minus.
Okay. Then we'll start at 8:30. We start at 10 a.m. Eastern, which means 9 a.m. Central, which means 7 a.m. PST.
It's okay. Yeah, I'm fine.
Okay. So yeah. So Shravani Kalaivani, the IST timing is 8:30 p.m. tonight. Okay. So 8:30 p.m.
So 11:30 EST, right?
10 a.m. 10
10
a.m.
a.m.
10. Okay, perfect.
Not PM, madam. It's AM.
a.m.
Thank you. Thanks for the clarification, Jax. Please give me a
Yes.
reminder before the class.
Oh, still we have one dropout. Okay.
Revti, are you there?
Okay. Oh, you have to go to office.
Yes,
Saturday.
yes.
No, not tomorrow. Today also we have we're off, right?
Oh, okay. Okay, Dharmesh, let's see. I mean, yeah. So since I was requesting from last 2 weeks, so let me make up this at least this week. Okay. So I have been skipping one session. Let's see if you go through the video, and if you have any issues, then we'll catch up. Okay. You're joining tonight as well. Oh. Okay. Okay. Let's see how it goes. Yeah. So next, let's start with Spark. So this basic overview we have already discussed about. And again, just for your revision, Spark is written in Scala. And obviously, since Scala is written in Java, Java runs on JVM, which means Scala runs on JVM, which means Spark also runs on JVM. Okay, Spark, Scala, Java, all these three run on JVM only. And Spark can also be, I mean, when you code Spark in Scala, in that case it runs in JVM. Spark can be used from Spark can be coded in all the languages like Python, Java, and Scala as well. But our main focus, as we know already, so would be through Scala, and that's the most popular combination as well across the industry, enterprise organizations. And to get started with your Spark, so by default, your quick start VMs, I'm hoping that you guys might have already downloaded the quick start VMs. If not, just let me know. I'll explain those steps as well. If you have already downloaded, you'll have a Spark already existing there. But if that is older version, if you want to start with the newer version and if you want to play with the daemons of Spark, so then download the binary tarball of it. And anyway, I will explain those steps as well. And for installing Spark on your own, so these are the prerequisites that we may need it. So at least JDK 7 or above is needed, and which comes by default in your quick start VMs, and Scala 10 or above, even that comes in your quick start VMs. And in case if anyone wants to install Python, you can install that as well using some yum installers.
Hi, Siva. You have any VM already pre-installed?
The Cloudera Quick Start VM already comes with in pre-installed one only. But on top of that, again, if you want to install, you can do that.
No, what I'm asking is if you already installed somewhere, right? Like already you have a package or something. So if you share that.
Shiva, Jax, I'll share it with you. I have that.
Okay, thank you.
Okay. I had it in my previous laptop, as I told you, that got crashed. I lost that. That's the reason why even I am starting with installing that once again.
Okay, no problem.
Okay. So, and Spark on high level, as I told you, Spark can be run in 3 modes mainly: Spark on Yarn, Spark on Mesos. This we might not be discussing much on this, only just theoretical points here and there, because even I don't have any Mesos framework available for showcasing this. Spark on standalone and Spark local mode. This many ways you can play with your Spark. And
so is there a batch processing or something in Spark? Like if it's a local mode,
yep,
do we have some batch processing?
yes, you can submit your jobs.
Okay.
You can submit your Spark jobs, and those can be executed as a Spark submit. Anyway, we'll discuss that. Okay. Now, so Spark can be executed in all these 3 or 4 means, but the most popular, the combination across the industry is a Spark on Yarn. Okay, and in your practicing, you'll see all these 3 ways: Spark on local mode, we'll see; Spark on standalone mode, we'll see; and Spark on Yarn also, I'll show you. Okay, and by default in your quick start VMs, it comes only with Spark local mode. And how to run the standalone and Yarn modes, so I'll show you. For that, you might need to download the binary tarballs. Okay, and if you guys, I hope everyone is aware of downloading a quick start VM from Cloudera.
Yeah.
And setting up using either VMware Workstation or Oracle VirtualBox. So will we be discussing Spark on Windows as well? No, Dhruva. So we'll not be discussing Spark on Windows, because in real time no one uses that. I mean, to be frank, even I don't recommend anyone to use that, and I never did that. From my previous batch, there was one candidate who used Spark on Windows. If you really need any suggestions, or you just try it out in Google how to set up in Windows, and if you need that, if you're stuck anywhere, I can ask so my previous batch student to help you on that, or I'll ask her to provide me the detailed steps for that, because no one runs Spark in real time on Windows. Okay. So I have 4.5 Cloudera. I don't think so that will be fine, Dharmesh. So at least you need a CDH 5.3 or above. Okay, so just download that and start opening that. So before getting started with the installations, I just want to check with everyone. So whether everyone is ready with the Quick Start VMs or not. Is anyone not having your Cloudera Quick Start VM? Okay, so you have CDH 5.3, I don't have, okay. But do you know the steps how to set up Kalaivani? Kalaivani, can you hear me? Do not know, Shiva, I'll get it from you. Okay, I'll ask Praveen to help you on that. So I don't have either, okay. Yeah, maybe I can give you the simple steps here in 2-3 minutes. But if you face any issues, I'll ask Praveen to help you for both of you, Kalaivani and Larissa. Okay?
Yes, sure.
Yep. Yeah, that is also fine, Larissa. So since Revati, even you don't have, how come? Okay. Okay, no problem. But in simple steps, I'll explain you what is how you can quickly set up on your own. So I'll share this VMware workstation.exe file with you. Let me open my Google Chrome. Okay. So since if you have any older versions of Quick Start VMs, I'll still recommend you to go start with the latest one only. So Quick Start VM download. Go here. So from my Google Drive, I will try to give access to this. So VMware workstation, this file, I'll share with whoever needs this. So to Kalai. And Larissa. I can't share it with Yahoo mail IDs, Chucks. That's the reason I need it. So I have it from our last batch, which is enough, right? I guess it has everything already installed. Yeah, that is fine, Raj. Okay. So, and gjax15gmail.com. And anyone else needed? Quick Start VM, VMware workstation. So please share with me also. I need Dharmesh. Okay. So Dharmesh, Ishwaran Paramashivam, Revati, Mahesh, your mail ID, please. Gmail ID. es.sujit. Anyone else? Yeah, gjax15, I shared it with you, Jagdish. Okay, so just download this and I will share the keys also for that. So these are the keys for that. So use either any one of these keys. Not able to copy this. So just use whichever key works for you. I'll put it in the today's notes. Okay. So now the steps are like, first download VMware workstation. workstation from the Google Drive shared folder and install and activate using below keys. Okay. So once you have this ready, so once you open your Quick Start VM, your VMware workstation, you will get a home page, not like this. Okay, not all these things. Yeah, once you download that and install it, next download the Cloudera Quick Start VM. So go to this cloudera.com downloads Quick Start VM. So download the latest one, whichever is available, CDH 5.8. Select that, select for VMware, okay, and get it now. And you might need to fill in some extra details like your name, phone number, and all those details. You can fill in whatever the details that you like. Okay, so there won't be any validation. You can put some XYZ values also. Then you'll be able to download it. Once you download this, then after your Quick Start or your VMware Workstation installation, go to File. So click Open. And so you might get the .zip file from this. You have to extract that. Once you extract that into any folder, then you go here and select for, search for that. Maybe if you download this way, so you'll see one file can be selectable, which is of .vmx extension. So if you open that, your Quick Start VM will come into this list of VMs that you have here. And on that, you try to allocate, let's say if you have this way, before you start them, you'll see this play button available for you. Otherwise, yeah, for the first time, you'll see all these three options. So try to allocate at least 6 to 8 GB. If you have only 8 GB RAM laptop, try to allocate at least 4.5 GB for that. Okay, and since I have 16 GB, I allocated just around 9.2 GB or something to this Quick Start VM. So just edit them, just increase here, that's it. And the processors also, if you have, maybe if your processor is i7, try to give 3 cores. If it is i5, just give 2 cores. 2 cores is enough. Then start this. Just power on this virtual machine. You will be logging into this kind of screen. It will not ask any passwords. You will get logged into your Quick Start VM. Okay. So I just summarized the steps needed. Okay, I didn't show you step by step. So download Quick Start VM. VM 5.8 and open it in VMware. Okay. Now once you have these things ready, so by default, you can verify whether your Spark is installed on it. Just go to user lib folders, go to the file system, user lib Spark. So as long as this is present, you'll be able to see the Spark is there. Spark shall try accessing this Spark shell using that spark-shell command. This opens your Spark in local mode. Okay, and so I would recommend you to start with the latest version of Spark. But let me see what is the version that I have in this quick start VM. So it's a Spark 1.3, which is a bit older. So let's not use this. So in your quick start VM 5.8, you might have a Spark 2.0. If it is any version above Spark 2.0, that's fine. If it is a bit older, then check your Hadoop version on your quick start VM using the Hadoop version. So here I have my Hadoop version as 2.6, CDH 5.4. Then go to the Spark downloads page. You simply type download Spark. You'll get the very first link, Spark downloads from Apache Spark. Then select the latest release that is available, the stable one, 2.0.1. And based on the Hadoop version that you have on your machine, so here I have Hadoop 2.6. So in the next, choose a package type, which is pre-built for Hadoop 2.6. Since I'm using CDH 5.4, I'm downloading it for the 2.6. If it is CDH 5.7 or above, so then you might need to go for pre-built for Hadoop 2.7 and later. Okay, select that and try to select the direct download only and click on this link. You will be able to see the download getting started. Once the downloads are started, you'll be able to find that downloaded file in the downloads folder. Go to Cloudera or this downloads folder. I can see this. So this is the latest version, Spark 2.0.1. This is a binary tarball file, gzip tarball. So installation steps are very simple. Just copy this and wherever you want to install. So let me install it in my home folder itself. Okay, so either you can install in home folder or user lib or OPT folders, wherever you want. But yeah, otherwise I'll put it in the /OPT. Okay, so here I will install. So for installing there, create a directory, and you will not have direct access to that. That's why I'm using sudo /opt/spark and sudo chmod -r77. I'm giving all the permissions so that I don't need to use sudo every time. Okay. Now, so I have this Spark created there. From downloads, I'll cut this Ctrl+X and paste it here. Extract there. Okay, the extraction is completed and you have this. Since this is a binary tarball, you don't need to do anything else. Just start using this either you can navigate to that folder every time /opt/spark and /bin and use ./spark-shell. Either you do this way every time, or you add this bin directory to the path environment variable in your quick start VM. So how you can set that inside your .bashrc file. gedit //.bashrc file. Okay, so export all the environment variables, whatever is needed. So it's good to have all these things. Spark home equal to this entire path. This is where we installed our Spark, right? So and export spark _conf which is $spark_home/conf folder. I'm assuming that exporting variables, all these things are familiar for you guys. That's why I'm not explaining much on that. And add the bin folder and as well as bin folder if there is anything. Yeah, add these two, both of them into your path environment variable. So export path equal to, so a $path colon your $spark_home/bin and :/sbin. So both binary bin folder and sbin folder, system binary and system binary folders. Once you add this, then by default, next time onwards, if you type the, or ideally we should put them in the beginning, otherwise your default ones will only get affected, will be take the precedence. Okay, so if you put in, if you prefix your Spark bin and sbin directories to the existing path, then your latest installation will get picked up. But if you suffix that, if you append at the end, then you still see that older Spark version only getting picked up. Okay, there is a difference, whether difference on where you are adding the Spark bin folders. So there is a lot of there are a lot of differences between the Spark 2.0 and Spark 1.3.0 that you have seen there. So you see a lot of log messages being printed there, and in Spark 2.0 the warning messages, the log level has set to only the warning messages. That's why you can only see the warning related stuff, can't see the informational messages here. Okay, so let me come out of this. Okay. So once you make the changes to your .bashrc file, so reopen your terminal. Something went wrong. Equal to is not a valid identifier. It's not a valid identifier.
Shiva, you might have a space after the equal to and before and after the equal to.
Oh,
It should be
okay.
together, maybe.
Okay. Okay. Yeah. So this time this got. So you can validate your values. Echo dollar Spark home. Yes, it's pointing to that. Conf and which Spark hyphen shell. Okay. So when I typed which Spark hyphen shell, it's pointing to our own installation directory, not the default one that shipped with your quick start VM. Okay. So now we are good to get started with Spark shell. So Spark shell is the local mode of execution in this in your quick start VMs, and you can run your Spark in standalone mode as well by running the Spark daemons. This is also like master slave architecture, so we'll anyway discuss that in the Spark architecture part of it, but just want to check what are the services that are running for Spark. So Spark history server is running, Spark submit is running. This is for Spark shell, but Spark master or Spark worker nodes are not running. Okay. So to run them, you can go to this and you can run those daemons as well from your sbin directory. They will be available for you. So either you can run Spark start all.sh or start master.sh for master and start slave.sh. Okay, so let me start them using the start all.sh. So it's opening the starting master, logging into the master. So why is it asking for password? So I think it should be Cloudera. Okay, so now the master and worker are also running. Okay, so I'm good then. Okay.
What's the port number for the Spark?
For master, it's a 7077. Anyway, we'll discuss all those things. I'm just trying to explain you the installation part of it. Okay. I'll explain you the port numbers and this. So when you when there is no master, there is no worker running. even then you can start your Spark shell. Okay, so if you start your Spark shell without even starting your master or worker machines, that is called as a local mode. When you simply start your Spark shell and in the background it's not tied with any master or worker, that is called local mode of execution. And standalone mode, you start your own master and your own worker node and submit a job to that master. That is called starting or running your Spark on a standalone mode. In yarn mode, you will not have a separate dedicated master or worker nodes running. Your resource manager will itself act as like a Spark master, and your node managers, on your node managers, your worker tasks will be running them. Okay. Anyway, we'll see all those things in detail again in the cluster level applications. Until then, we'll be practicing all our Spark examples and code in Spark local mode. So for now, you just focus on this. And once we discuss the cluster applications, you will see the more in detailed differences between those things. Okay, Spark 1.6, okay. Yeah, hopefully that should be okay. As CDH 5.7, it's Hadoop 2.6. And Spark 1.6, yeah, that's still okay. Not an issue. Have CDH 5.8, Hadoop 2.6 and Spark 1.6. Yeah, even that is fine. We'll upgrade to 2.x. I have Hadoop 2.2 and Spark 1.5.2 is this one. I would recommend for you to upgrade, Shravani. Hadoop 2.2 is a bit older. In prod, it will be yarn mode, right? Yes. So, or instead of maintaining this many confusions, I would recommend everyone to download the Quick Start VM 5.8, the latest one, and download your Spark tarball for 2.x, okay, and install using the way I have shown you in just now. Let's use the latest Quick Start VM. On inside that latest Quick Start VM, let's use the latest Spark version. Okay, but for your interview purposes, you say that you worked on Spark 1.3, 1.5, 1.6, all those things. But for now, start practicing on the latest version only. There are some changes from version to version that I observed. Okay, so at least if you practice on the latest version, even I get to know that. Yeah, in our cluster, in our client clusters, we have Spark 1.6, 1.6.1 actually, 1.6.1, and that was also recently got upgraded from Spark 1.5.2. Okay. Hey, just one quick question. Do you guys hear lots of background noise from my side?
Yes, Shiva.
It's not much, but it's okay, Shiva. Nearly wants to buy some vegetables back.
Yeah.
And you can go ahead and order from my side. Shiva, do they have a Costco delivery there?
What is it?
Do they have a Costco delivery there?
No. They come directly to your flats.
Your house, yeah.
Did you move your house? You don't have the temple anymore or what near your house?
Yeah, that I'm not. Yeah, I moved from that house. No more that. What do you call coil sounds?
And the
Oh,
temple bells are also gone now.
Yeah,
now only back end is vegetables.
How come I didn't hear any rickshaw honking or any scooter honking?
it's there. It's there. Rickshaw sound is coming for me.
That's so
Auto
nice.
sound. Auto sound. So I closed all my doors, but still, these are not like soundproof flats, right?
That's India. That's a feel of, you're giving us a feel of India. That's fine.
Yeah, I mean, I just wanted to check with you whether you guys are okay, or you getting disturbed, or
No. It's nice. No, we're not going to disturb. It's okay. Go ahead.
okay.
Jax, are you getting disturbed?
No. I'm scared. Like you will go and buy vegetables in India.
Okay, good that you are enjoying it.
No, we usually know, right? Like in the morning they'll come and
Yeah,
like
and
still I remember all those. So okay, I was
Bringing childhood memories back, huh, Jax?
okay, and so these are the different modes of Spark you can run, but as of now, so we have seen only two. So one is a Spark local mode, which you simply start your Spark shell. Okay, and so second way is running your Spark master and worker nodes and pointing your Spark shell to that master using Spark standalone, but that I didn't show you yet. But when you start your Spark shell with just the command Spark -shell, by default it opens you in your local mode only. Okay, it opens in your local mode only. For now, focus on this, the local mode of execution. In cluster applications, I'll again explain you the cluster architecture of standalone and as well as cluster architecture of yarn. And inside standalone, you can have a pseudo standalone as well as fully distributed standalone, and even the same like your yarn, right? So even though it's having different JVMs in your quick start VM, that is a pseudo distributed. Okay, so we'll see that. So I hope you guys are clear with setting up basic quick start VM and Spark installation there. And these commands were helpful till CDH 5.3 onwards. After that, they didn't enable the master or worker node daemons available in your quick start VMs by default. That's the reason why I downloaded this binary tarball. There I have this Spark master and Spark worker nodes daemons available. Earlier, without you downloading and installing it, you still able to run your Spark both in local mode and as well as in standalone mode.
What is this master and worker thing? Can you just tell again?
Yes. I'll come to explain the architecture. Okay.
Okay.
I'll explain them in the architecture. Okay. Now, so what is the difference between local mode and standalone mode?
Local is local and standalone is standalone.
Okay, so local mode means, so how many ever daemons that you need for your Spark execution, if all of them run in the same JVM, in one single JVM, that is called local mode of execution.
Shiva, can you repeat that again?
All the Spark daemons run in the same JVM that is called as local mode of execution.
Okay.
Same like you guys were executing your MapReduce programs in the Eclipse, right?
Yeah.
When you are running in Eclipse, so it was not connecting to your Yarn resource manager actually. Your resource manager and node manager, everything runs on your Eclipse only, Eclipse JVM only. So that is local mode of execution. When you prepare a jar and submit on the terminal, then it was running, it was submitting to Yarn resource manager and tasks being run by node managers. That is called as a distributed mode. Since they both are running on the same machine, we were calling that as a pseudo distributed mode. In the same way, in standalone, again, why we call that as standalone? When you are not depending on any other frameworks like Yarn or Mesos, but still your Spark is running in a distributed mode, that is a standalone distributed mode. Okay. I mean, this is again, I'm giving you very high level here. So when we discuss about the cluster applications, I'll again explain you what is standalone mode, what is Yarn mode, what are the all the different daemons that are available. Or yeah, sometimes I used to get the suggestion from people that I would take up the architecture first and then take up the coding part of it. Maybe if that's the case, I'm thinking. Okay, then I'll explain the architecture first. I'll share this. Or I'll share my screen only. I make use of the paint. Okay, yeah, first let me talk about architecture. Then it makes sense you to explain the different modes of the Spark executions. Okay, so same like your Hadoop HDFS master slave architecture or Yarn master slave architecture or HBase master slave architecture, your Spark is also of a master slave architecture, and it's a distribution framework. So here you will have a client. This is your client. So once you submit, let's assume you have written some Spark code, you are submitting that will get submitted to your Spark master. Sorry. And Spark master will send those instructions to your workers. Okay. This is equivalent to your resource manager when you compare with your Yarn master slave architecture. This is resource manager and this is node manager. And this client machine, wherever you are running the Spark program, that we call as a Spark driver. The architecture is very simple. Okay. On your client machine, whatever the Spark program that you write, that Spark program where the execution starts, that is called as a driver. this is your driver, and the driver sends instructions to the master. First it connects to master, and your actual task will get executed on the worker nodes. This is again bit high level. Is it clear, or you want me to explain once again?
We don't have any name node concept here, only resource manager and node manager.
Okay, so you asked a good question, but so before asking that question, you should identify the differences between your Hadoop and Spark. Spark is not a file system to have a name. Okay, Spark still runs on your HDFS, meaning it still needs a kind of file system. Spark supports all the file systems, like your local file system is supported, your HDFS is supported, your HBase is supported, your Cassandra is also supported, and some other connectors are there for other kinds of NoSQL databases like MongoDB and Cassandra and other stuff as well. Even S3 is there. Now, so since you asked that question, so I'm explaining this concept once again. Spark is not a competitor for your HDFS. Is not a competitor for competitor might be a good word some use cases, but it's not a replacement for your Hadoop. Inside your Hadoop, you have two major frameworks. One is HDFS. HDFS is one framework, and Yarn is a second framework. Correct? So HDFS is for storage. So this is a file system, and Yarn is a resource management system. Resource management system. Now, what is MapReduce? It's a processing engine. Can anyone tell me the differences between Yarn and MapReduce?
The Yarn was the older version and the MapReduce is the upgraded version of Hadoop?
No. I mean,
No,
first of all, the answer is
MapReduce.
reverse. Yeah, the answer is reverse.
Other way around.
Yeah, other way around.
I was close.
You're not close.
Come on. At midnight, what do you expect me? I can shuffle a little bit.
Many people, even though they are working on this Yarn, they don't understand the differences between what is MapReduce and what is Yarn role exactly, and how Yarn got separately introduced into the Hadoop ecosystem when MapReduce was not able to solve the purposes of it. So, can anyone try? So at least tell me whether in a Hadoop 2.7, let's say in the latest Hadoop that you guys are using, so are we using MapReduce or not? Are we using Yarn or MapReduce?
Yarn.
Yarn is a framework.
Correct.
And aren't you writing your MapReduce programs?
So your job tracker job has been divided to 2 tasks, like an application master and resource manager.
Okay. So
In
that
Yarn.
means
So isn't MRv2 and Yarn same thing?
no.
Shiva, I think the Yarn, right? It is a new framework kind of thing wherein you can have another like Spark, Mesos, and other kind of processing engine working.
Mm-hmm.
I think it's both are same, right?
Both are same MapReduce, yeah.
No, but the
So,
map
I think-
reduces run that Yarn enabled cluster.
So Shiva, I think Yarn is just for dynamic allocation of the cluster resources and to improve the utilization of the resources in the Hadoop
Mm-hmm.
using MapReduce rules again.
Who is this? Dhruva. Yeah.
Yeah.
So you're closer. 90%. The answer is correct.
Shiva, Yarn is like a framework. It is handling the data node allocation and that master node allocation something. That MapReduce is processing of the data actually.
Yep. So yeah, so let me make it. Let me elaborate this so that everyone will be on the same page. So how exactly Spark can be fit in this? Okay. So then you will. I mean, this is all. Since yeah, I mean, not just for your question, Dharmesh. Why I entered into this topic is so many people will have lots of confusion. They keep asking me what is the replication factor in Spark, what is name node equivalent in Spark, these kind of questions. So here HDFS is file system, everyone is clear. Yarn and MRv2. So ideally speaking, the MRv2 and Yarn, they both are not same, ideally speaking. But people keep calling them, giving aliases that way. In MRv1 architecture, again I'll repeating that, MRv1 architecture, you have a job tracker, you have task tracker. Okay. Under this job tracker, there is any client submitting a MapReduce job, MR job, your MRv1 architecture, this MapReduce job, when you submit to job tracker, the job tracker is responsible for so many tasks. So one out of them is job scheduling. Okay. And once the job is submitted, job monitoring. Okay. And progress updates. Progress updates collection and communicating the same thing to client, and task failure handling, all these things. Okay. So job scheduling and allocation of resources. So this many duties were there for job tracker. And task tracker was
Shiva, process updates collection. What is?
Progress update collection means like each map task, how much percentage it got completed. Okay. So how much progress each map task is completed, each reduced task, how much is completed.
Okay, sure, yes.
Okay. So all these were the duties of your job tracker. In task tracker, so it was submitting your map and reduced tasks and executing them. Map or reduced tasks. Now, so here, the purpose of this job tracker or task tracker This is a resource management kind of framework. But when you write your program, where exactly all your processing is happening? Inside your map and reduce tasks, right? Inside your map and reduce logic, the program that you have written, the map method or reduce method that you have written, those methods are responsible for processing your input files. So all your processing happens using this in terms of map and reduce tasks. Map and reduce tasks. Now, since this job tracker was only one instance in the cluster, and since it is having this many tasks, it was not able to scale beyond certain requests. Okay, so that's the reason they separated it out, all these duties into separate daemons. So allocation of resources or resource management, so it got separated it into. So allocation of resources is now being handled by a resource manager, and scheduler is also there, but it's the responsibility of your resource manager only, but it uses its own algorithm for that. But only these two are the responsibilities of your resource manager in Yarn. And the other stuff, these three tasks, job monitoring and collection of the tasks updates and task failure handlings and all other things got separated out into app master. Okay, so this is Yarn resource manager, and so half of its duties got leveraged or assigned to app master, and this task tracker got changed to node manager. So here you don't need to worry about whether it's a map task or reduced task. It runs them Yarn chains. We call them as Yarn chains. This is a Yarn chain task. Now, in the earlier MRV1 architecture, both your resource management daemons, these are resource management daemons, right? Job tracker and task tracker, and your processing tasks are tightly coupled. Other than map or reduce tasks, you can't run any other kinds of tasks on this task trackers. Now, they separated it out. The resource management.
Shiva, tightly coupled means, sorry, tightly couples means what it is meaning here?
Okay, so tightly coupled means you can run only the map and reduce tasks on your task trackers, not any other tasks, any other types of tasks. Okay, so here they in the second release of this in Yarn, they wanted to separate out the resource management and processing part of it. So in the Yarn resource manager, in the name itself, yet another resource negotiator, Yarn means. So you have these three components which are responsible for managing your resources. So a client will make a request to resource manager, and resource manager will allocate a application master. Application master validates how many tasks are needed or how many containers needed for running your job. So it calculates it evaluates based on how many containers are needed. So based on that containers, it will start all those containers on node managers, and in each of those containers, it starts the yarn child tasks. Now inside these yarn chails, you can run any kinds of tasks. So inside these yarn child is nothing but a particular JVM. That's it. Is a type of JVM. Inside this JVM, you can run map task, you can run reduce task, you can run a Tej task, you can run a Spark task. This is a generic, a global umbrella JVM under which you can run any kinds of tasks. Because this resource management is now being handled through a containers concept. So container is nothing but some amount of RAM and CPU cores. Using this, some maybe 4 GB or 8 GB and 1 or 2 CPU cores, your JVM will get kick-started. And inside that JVM, you can run any kinds of tasks. That's the reason, even though you got migrated to Yarn, you can still run your MapReduce jobs. And you still have that map phase, reduce phase, map task, reduce task, all those things. And only the class names got changed. The resource management framework got separated it out. Your MapReduce, the processing part of it, the processing tasks, map or reduce tasks are still, you are running under the same Yarn umbrella. Now, since this Yarn chails are generic JVMs, you can run, you can use them for any tasks. That's the reason Hortonworks came with another processing engine that is called a Tej. Tej can also be run, Tej tasks can also be run under the same JVM. And Tej used to give almost 4 times faster the performance. Tej gives you almost 4 times faster than performance. Now, Spark came into picture. Spark came into the market. So Spark can have its own resource management, or Spark tasks can also be run similarly parallel to, or Spark tasks can also be run parallel to your MR tasks or Tej tasks under this Yarn JVMs, under this Yarn child JVMs. Now, if you run your Spark tasks under this Yarn child JVMs, you don't need any specific master and slave daemons from Spark at all. But before this integration came into existence, so Spark had its own master. Okay, same like if I'm a client, I have written my Spark program. So someone should give me the resources for that. So that someone is called as Spark master. And the slave machines that execute the tasks, we call them as a Spark worker nodes. Spark worker nodes or executors, any of these. So when you are not dependent on your Hadoop cluster, okay, so that means you can run your Spark independently without relying on your Hadoop, without depending on your Hadoop framework at all. So in that case, if you are not dependent on your Hadoop at all, then in that case, there should be one master and some slave machines that should be available for your distribution execution. Correct? So when you are not depending on any of the existing resource management frameworks, then you call this Spark is running in a standalone mode. For standalone mode, you need an explicit master daemon running on one of the machines and Spark worker tasks running on the slave machines. And these come into existence only in standalone mode, where this is still a distributed mode. Okay, this is also a distributed mode, but Spark standalone means Spark can run on its own. It need not to wait, or it need not to depend on any other frameworks like Yarn or any other resource management framework. But they have their own pros and cons that we'll discuss sometime later. But if you don't want to maintain the resources by yourself, and you already have an existing Hadoop cluster, and you want all your resources to be maintained by one guy instead of having too many masters, you want all your resources of your cluster to be maintained by one guy, and that one guy, if you want like to be that Yarn, yes, then you can get rid of this master. You don't need this master, and you don't need to explicitly run your worker nodes. You can integrate that with your Spark node managers. Your executors will get started in this Yarn chains.
So Shiva, one question. When we run standalone mode, I can still use the Hadoop file system, right?
Yes, you can still use the Hadoop file system.
And can I access the local file system?
Exactly. Yeah, file system is accessible in all the modes. Okay, all the file systems.
Okay, all right. Thanks.
Okay, so file systems can be accessible both in standalone mode or in Yarn mode or any other modes. All the file systems. Because file system uses, it's a different URI, right? It's a different IPC. So if you give a HDFS colon your name node colon 8020, using that HDFS IPC, Avro IPC, it communicates with that file system. Nothing to do with your resource manager.
Okay.
Okay, so now this one here, if you are not relying on any of this, in that case, so you call about master, you call worker nodes, the slave machines. But when you integrate this with Yarn, no need of a separate master, separate worker nodes running, separate worker, this task running. They can run under the same node manager, Yarn chains, they can be running. Okay. So now you got the difference between standalone mode and Yarn mode, right? And when you run local mode, since you need one master and slave machines, local mode means both master and worker running in the same JVM. Example is like starting your Spark shell in your quick start VMs. While running your Spark shell in your quick start VM, in the back end, if you observe how many daemons are running So you'll not see any master or any worker node specifically getting started. Only this Spark shell task will be running. Okay, Spark history server, let's not worry about this. It's same like your MapReduce history server that we have. We'll talk that sometime later. Okay, let's not bring that into the existing architecture. Now, is it clear, the understanding the difference between your standalone mode and yarn mode? Okay. Yeah, thanks, Sarmesh. And you got the difference between standalone mode and as well as local mode, correct?
Yeah.
Okay. And if you go for Mesos, even Mesos is also similar to your Yarn resource manager, Yarn framework. There also you will have a Mesos master and Mesos slaves. Okay, but I personally don't have any experience on that. So I have worked on standalone mode, but we had some issues. I'll explain you why Yarn mode is more better than Spark standalone mode when you already have a existing Yarn architecture or Yarn cluster available in your machines. For now, at least you have the clear-cut understanding that the differences between Spark running in a standalone mode, Spark running in a Yarn mode, Spark running in a local mode.
Shiva, again the basic question.
Yep.
I'll forget about the Spark. Okay. The Yarn enabled cluster, we have a resource manager, node manager, and
application master.
No, still we have a name node, right?
Yep, name node is still there. That is HDFS. I'm not touching your HDFS file system. That will still be.
I couldn't relate HDFS and okay, I got it. So even in Spark, we have a name node concept that is HDFS.
Yes.
Okay.
If you want to communicate with your HDFS file system, you still have to communicate through that name node. Okay. You should not be calling that. Even in Spark, we have name node. Spark is different. HDFS is different.
Yep. So that's where we have the metadata so that the resource manager can get.
Yep. Exactly. Exactly. And if you guys remember that Yarn architecture and Yarn job anatomy, the same job anatomy when you run a Spark job on Yarn. So the client request will be sent to resource manager and resource manager to application master to node managers, and node managers inside Yarn chains. Inside Yarn chains, your Spark tasks will be run. And unlike your MapReduce framework, you don't have a map task or reduce task kind of differentiation in Spark. Everything is a task. It's just a task. That's it. Whatever the operation that you do, that is just a task. That's it.
Shiva, one question here.
Yes.
So let's say you're running your Spark in standalone mode. Will you be still able to access the HDFS files or like?
Yes. Yes. See, Spark you are running in a standalone mode. Now HDFS is there. HDFS is there on a cluster. See, it's not just your Spark. You can access your HDFS file system without need for your Yarn framework. That's what we teach, right? Like wherever you want to access, just specify this name node :8020 and provide your user /Dhruva/ some file.txt. Okay. So this HDFS, this has its own communication mechanism through Avro.
Correct. Yeah.
You don't need a resource manager to read this file.
Okay. So every time you just whenever you need some data from HDFS, you just specify this path and then you just read from there, right?
Yeah, that's it. It
Doesn't
opens
matter
a
if
connection. Yeah, for your question, maybe if you have any question, it opens a connection to this file using the HDFS Java client.
Correct. Yeah.
Java client. What are those classes? DFS output stream or DFS input stream classes are there, right?
Right. Yeah.
So these classes will be used to make a connection to this file system.
Okay. Got it. Yeah. Thanks.
Okay. So maybe if you understood the differences between the different modes, I'll stop it here. And in the evening class, we'll get started with the basic simple Spark hello world or whatever it is. Any questions? This understanding is very, very important. So out of the today's discussed topics, this one is very important. Map, filter, reduce, flat map for each, and understanding the modes of Spark. Even, I mean, there are guys who are working for more than 2 years and they don't know what's the difference between standalone, yarn, and local modes, and when they will provide the master URLs and when they won't provide. And so, yeah, because I do take these interviews, right? So that's where I'm telling all these things.
Shiva, have you published the interview questions on Spark on your website?
Not much, Snehali.
Please update it.
I need a help from like guys like Praveen. So yeah.
Praveen and Shiva, please update it. At least we can read and understand that part.
Yeah, sure.
Hi Shiva.
Yeah, hi Sunil.
Yeah, your website is not working from couple of days. I am looking into it.
Couple of days?
Yeah, I think 2-3 days it's not. I'm not accessible to that.
Maybe some catchy issue. Why don't you?
Because in office I just go to this URL when I got time, but it's not opening up.
It's opening for me.
Means some proxy settings maybe.
Yeah, might be some proxy settings, something issues.
Okay, fine. Thank you.
Any other questions? Okay. So if not, let's meet at 10 a.m. Eastern, 9 a.m. Central, 7 a.m. PST, and 8:30 p.m. India timing tonight. Okay. Thank you guys. Thanks a lot for your patience and extending. Bye-bye.
Bye.
Bye, Shiva.
Bye.